Welcome, friends. We have, since the coronavirus infection has spread throughout the world, and it has been considered as a pandemic disease. I think we must have some knowledge about the coronavirus, for which I have made this video tutorial in which we'll be discussing what is coronavirus disease and what is the mode of transmission of this disease, how this disease attacks the person, and what is going to happen, what is the mechanism of action of this disease, and so many things in this video tutorial. The first thing is, what is a coronavirus disease? Coronavirus disease, which is encountering this time in the community, in the world, is basically a viral disease. A viral disease which is caused by coronavirus. It is caused by coronavirus. The 2019 outbreak of coronavirus is caused by coronavirus, and this virus is basically present in case of animals. This is being seen present in the animals, and from animals it may occasionally spread to the humans. It may occasionally spread to the humans, and from humans it can be taken up by the other humans by direct contact. So these coronavirus diseases, we have witnessed these coronavirus diseases from past 2 decades. If we see, the first coronavirus infection was in the year 2002, which we call as SARS, severe acute respiratory syndrome. We have witnessed this disease, which was caused by the coronavirus in the year 2002, which we commonly called as SARS. And second thing, we call it as Middle East respiratory syndrome. This was witnessed in the year 2012, again a corona type infection of respiratory tract. And now we are in the year 2019. Just 3 months back, we have witnessed the coronavirus disease, which we call as COVID-19. COVID-19 means corona virus disease of 2019. This coronavirus, basically these are also coronavirus diseases, but we have witnessed it one time, second time, and now we are witnessing it at the third time. But this time the virus has mutated itself. It has made some changes in its genotype, in its structure. That's why we are more worried, because we are not ready. We are not prepared how to handle the virus. So when we see this coronavirus 2019, it has a structure. It contains positive sense. RNA as it is genetic material. It has positive sense RNA as it is genetic material, and it is covered by some spikes. It has some spikes, protein spikes, and these spikes are made up of proteins and are covering this virus, and it is just giving him a resemblance with that of the sun. And the second thing is, what is the mode of spread of this infection? That's very, very important. How the virus spreads from person to person. If we see this disease has been derived from the bat. The real origin of this disease has been traced out from the bat. And if we see SARS of 2002, it was also coming from the bat. Now this time it comes from the bat, and then it has infected some intermediate host. Ultimately it has reached to the man. And the most important feature of this disease is the transmission from man to man, which is very rapid, very fast, and very, very problematic. See, the mode of the route of infection, the mode of infection of this disease is the first thing we can see. It spreads by droplet infection. Droplet infection means it spreads from one person, infected person, to some virgin person, to some another person through sneezing, through coughing, or through the direct contact. For example, if there's a person, he has this coronavirus infection, he has some respiratory problems as well, and with the result he may be sneezing, he may be coughing, he may have some symptoms like sneezing and coughing. Once he will sneeze or once he will cough, he will liberate a droplet of infection which contains a large number of virus particles. These virus particles have a great problem, that is, they remain in the air for some hours, maybe 3 hours. This person has gone, the infected person has gone. Probably some other person who is not infected will come through this path, and ultimately he may get the droplet, he may get the infection, he may get contaminated with the virus, he may take the virus. This is one concern. And second concern which we have, the virus, after remaining some time for a period of 3 hours in the air, has a tendency to settle down. Once it settles down, it will definitely contaminate the surface to which it has made a contact. So therefore on this surface the virus will remain live for maybe some say it is for 1 day, for 2 days also, or even some claim that he may remain live for 3 days also. That's the most worried thing about this. So the spread of this infection is very, very fast. We call it as an exponential increase. Exponential increase. Once we detect the cases, once we detect any one case, we are finding a fast spread of this disease, because the first person, for example, if it simply infects 3 persons, I can just put it in this way. If a single person which is infected with this disease is transmitting the disease to 3 persons, the 3 persons will transfer, from these 3 persons will transfer the disease to 9 persons, and these 9 to so many. So this is an exponential increase which is making us more worried. So this is what we can say about the incubation period. And incubation period of this disease is approximately 14 days. Incubation period means the day from which we have contacted the infection, or we have taken the infection, up to the appearance of symptoms, because symptoms do not appear instantaneously. It takes some time. The virus takes some time to develop inside the body, and the time from the day of entry of the virus up to the appearance of first symptom is being called as incubation period. And the incubation period is 14 days, or it may be as short as 5 days. The persons may exhibit the symptoms in 5 days or 14 days. Let us see the mechanism of action of this virus. For example, we have coronavirus. If it infects any person, if we see the structure of coronavirus, in the coronavirus we have protein spikes. You have protein spikes, large number of protein spikes, and these protein spikes, some of these protein spikes may have S proteins. Some of the protein spikes may be S proteins, and the receptor site for the binding of this coronavirus infection, coronavirus virus, is basically located on the cell membrane, and this is known as ACE2 receptor. So the binding of coronavirus is mediated with the help of ACE2 receptors, which are present on the cell membrane, and we consider them as transmembrane proteins. Once it has this ACE2 has a receptor site. For example, this is the receptor site, and this receptor site, in this receptor site, this S protein is going to hook. This S protein of the virus, docks on the receptor site. That's a receptor site of ACE2. Once this binding takes place, there is activation of another protease which we call as TMPRSS2. Activation of TMPRSS2. This TMPRSS2 also known as serine protease. We call it as serine protease. So binding of this with this will activate TMPRSS2 or serine protease. By way of this, it will internalize. Suppose this is the genetic material of coronavirus, which we consider as RNA. This activation of serine protease will internalize will internalize and will facilitate the movement of this RNA, positive sense RNA, into the cell, into the cell. So what is going to happen inside the cell? The RNA will start replicating. It will start replicating. There will be viral replication, which we call as lysogenic phase of virus. So viral replication will be taking place and number of viruses will be formed. Right now, we are really very much concerned in how to get rid of this virus, how to target this virus, and the target sites which are right now in discussion in which are debatable right now are basically these two. One is the TMPR SS2 serine protease. We have to make some drug, or we have to make some molecule which will be against this serine protease. We can say anti-serine protease. We have to make something which is anti-serine protease, which is going to target the serine protease, and it will not allow the genetic material of the coronavirus to enter into the cell. Or we have to make some anti-ACE2 antibodies, by which we can kill these ACE2 receptors which are present on the cell membrane, and we can also get rid of this virus, because this will not allow the binding site of the virus to not be available in our cells, and ultimately we can make some control, we can make some curative measure, a therapeutic measure for getting relieved from this infection. Then next, presently we have a rumor that the patients who are diabetic and who have some hypertension are more prone for getting a fatal coronavirus disease. How far this fact is true? It is being presumed everywhere that those patients who are taking the medication for diabetes and those who are taking the medication for blood pressure are more prone to these disorders. For understanding this, whether they are really, because we have a good number of population who are diabetic, who have diabetic hypertension, and who are on the medicines. We have two types of medicines, that's ACE inhibitors, or we may have ARB blockers. Now, for understanding this thing, we must go to the mechanism of action. If we see, first of all, we have angiotensin. Angiotensin is converted into angiotensin 1 in the kidneys with the help of enzyme which we call as renin. Renin is enzyme secreted by the kidneys which convert angiotensin to angiotensin 1, and this angiotensin 1 is converted into angiotensin 2 by ACE, angiotensin converting enzyme. So angiotensin converting enzyme will convert angiotensin 1 to angiotensin 2. Now, whenever we have some vasodilations, whenever we have decrease in cardiac output, whenever we have decrease in blood pressure, this is the counter-regulatory mechanism which is increasing the blood pressure. By that way, this is the natural system which is getting operational in our body for increasing the blood pressure, in which angiotensin is converted into angiotensin 1 and angiotensin 1 to angiotensin 2 with the help of renin and with the help of angiotensin converting enzyme. This angiotensin 2 has a receptor which we call as angiotensin 2 receptor 1, and angiotensin 2 receptor 1 will be acted upon by the angiotensin 2, and it will lead to vasoconstriction, and it will lead to increase in blood pressure, increase in vascular permeability, which will lead to edema, and it may also lead to ARDS, acute respiratory distress syndrome. Now we have to see, is this notion correct or not? What we are using in hypertension, we are basically giving some drugs which have two mechanisms of action. Some drugs are ACE blockers. One type of drug is ACE blockers. Some drugs have been designed on this mechanism. They are ACE blockers. They are basically blocking the ACE, angiotensin converting enzyme, and by blocking this ACE, we will not be getting more number of angiotensin second. This will not take place, and angiotensin second if will be in very less quantities. It is not going to be harmful because it will not increase the blood pressure. By that way, we can get rid of some cardiovascular diseases, we can get rid of hypertension and other things. And second type of drugs which we are commonly using are basically angiotensin receptor binding blockers. Angiotensin ARBs. We have angiotensin receptor binding blockers, inhibitors. See, what these drugs have to do, they are basically, for example, this is a drug. They are basically increasing the COX. They are basically increasing the receptors, which we commonly call as ACE2 receptors, ACE2 proteins. And suppose we have ACE2 protein here. This is the ACE2 protein. They will increase the number of ACE2 proteins, and this ACE2 protein, ACE second protein, will be binding with ATI. So they will allow the binding of ACE2 with AT1. Once this binding will take place, AT1 will not be available, and when there is no AT1, when there is less availability of AT1, we will not be getting these things, and we can simply correct the increase in blood pressure. We can get relief from the increase in blood pressure, because now this we will not be having this AT1 available, because this AT1 will be binding with ACE second, and the function of ARB is to increase the number of ACE and making this association possible. Now, why there is a threat for this? Since this ACE2 receptor, we have already discussed it. The mechanism of action of coronavirus is by way of binding with the ACE second receptor, and therefore this ACE2 receptor has a binding site for AT1, and it also has a binding site with the coronavirus. And what is going to happen if we give ACE inhibitors, or we will give ARB blockers? What is going to happen? We are simply increasing the number of ACE2 receptors, and more ACE2 receptors means we are giving more binding sites for the virus. We are providing more binding sites to the virus, and more binding sites to the virus will make the attack of virus more pathogenic and more invasive, because it will be easier for virus to come into the cell more rapidly when there are availability of large number of ACE2 receptors, which are possible by way of providing antihypertensive drugs in patients who have the problem of pulmonary hypertension. Now, according to this, once this report has been hypothesized, once this report has been published in the European countries, really there was a threat. People stopped taking antihypertensive medication, but ultimately the European Union of Cardiology has reported that this hypothesis is really not true, because the loss which we are getting by restraining the antihypertensive drugs is much more than the loss which we can do by this coronavirus. So therefore, this is the hypothesis, and usually it is recommended by the cardiology, but it is also hypothesized by some research papers that the mechanism of action of antihypertensive drugs is this, and we must not take the antihypertensive drugs. But at the same time, the European Union of Cardiology is much concerned about not taking these antihypertensive drugs, because it will also lead to some disorders, which may be some cardiovascular abnormalities, which may be very fatal. And then now we will discuss some other parts of this disease. We will see what are the signs and symptoms of this disease. It may involve mainly two systems. One is primarily it will involve the respiratory system, and it may also involve the gastrointestinal system. In the respiratory system, there may be simple fever, maybe there may be some cough. We can say there may be some cough or some fever, and in some cases, it may lead to viral pneumonia, and in some very rare cases, it may lead to SARS, that's severe acute respiratory distress. And at that time, the patient may require the ventilator support. But we have something to conclude. We are very much feared with this viral infection. Those patients who are getting this viral infection usually come out of the hospitals and they escape from the hospitals because of the fright of this virus. Is it really good to spread the amount of fright caused by this virus, or it is just we are doing it in a wrong way? For example, I will tell you one thing. Let's take the mortality rate. We will see whether we are really the amount of the quantum of fear which we are creating with this coronavirus infection. Is it really good or not? Let us see it by this way. Latest update as on March 20. If I will see right now, the total number of cases so far as throughout the globe is 2,52044, 2,52,000, approximately 2.5 lakh. And there are affected cases who have developed this infection. And number of deaths, we have 10,405. The first was the leading country where there were more deaths was China, but the second country which we have is the Italy, but I think Italy has surpassed the China so far as the death ratio is concerned. And when we arrive at the mortality rate, it is 4.1. 4.1% is the mortality rate. That means in 100 people, 100 affected people, only 4% of people will die. They have the chances to die. Suppose we have 18. We have seen in this COVID-19, 80% of the infected cases have very less symptoms, very minor symptoms, and they need not to go to hospital even. And if we see these 80% develop some mild symptoms, maybe some upper respiratory tract symptoms, not lower respiratory tract, and there are 15% of the people, infected people, who may require hospitalization, simple hospitalization, and there are really 5% of the people who require critical care. They may have developed ARDS, and they may be requiring the ventilators and other things. And when we arrive to the mortality rate, it is 4.1, and when we arrive to the number of critical cases, it is just 5%. So the mortality rate is not very high. If we compare this disease with the SARS 2002, the mortality rate of SARS 2002 caused by the corona type virus is approximately 10%. So right now the mortality rate is 4.1, and in 2002 the mortality rate was 10%, much higher than the present mortality rate. Then why we are worried about this disease? We should not worry. If somebody really get the coronavirus infection, he need not worry. But we have to be very cautious as well. We have to be very sensitive as well, so far as the social responsibility is concerned, because here the spread, here it was 10%, here the mortality was 10%, but it is 4.1%. But the amount of spread of the virus is very huge, and as we have seen, it has infected 2,52,000 people around the globe. Therefore, one thing is very important, that we have to prevent the spread of this disease by staying completely locked and indoors. This has really proved by the China. Today there was no positive case detected by the China, and they have really fighted against this virus, and the people of the China have completely completely followed the regulations of the government. In this way also, we should really follow the regulations, whatever comes from the government side, whatever comes from the expert side, and we should prevent the spread of this disease. That's all we have to say so far as this latest update is concerned.
हाँ